Thank you, Brian. Good morning, everybody, and thank you so much for joining today. I want to give a quick intro to Red Hat and what we can do for you. Red Hat has 5 major practices. Today, we're going to be focusing in on, obviously, OpenShift, but cloud automation DevOps is what we do in our group. Stephen is the cloud architect. He'll be speaking here in a minute, but we have an amazing practice around Kubernetes, ANSIBLE, OpenShift, where we can train you, we can give you a little overview, or we can come in and ideally set up a POC and get you started with the advanced environments that Red Hat offers. So make sure to ask those questions. We're here to help and do what we can. And with that little intro, I will hand it over to Stephen.
Hey, everybody. By way of intro, I guess first, before the agenda, this is me. I'm Stephen Tobias. I'm a CS guy turned Windows and Linux engineer. Check me out on GitHub. I like to put that out there in my webinars. A lot of the stuff I do, I try to put on my GitHub. So what are we going to talk about today? We're going to talk about OpenShift. Oops, I've got a little typo at the top. We're actually going to talk about OpenShift today, not Ansible. And so I'm going to start by giving a little background about Kubernetes and, why do we even care? And then I'm going to show you, how we can get started with OpenShift right from installation through to day 2 stuff through what we call the operator framework. And then I want to do kind of an overview of what the developer experience looks like in OpenShift. And yeah, we'll take from there. It's a little demo heavy. Please feel free to ask questions along the way, and let's get started. All right, so in general, right, why do we care about Kubernetes? Things are changing a lot right now in the IT space. People keep saying this word. It's a funky word. Why do we care? And really, it's because kind of the IT landscape has changed. It's gone from this idea, or this methodology, or kind of concept of IT being support, and IT is really kind of driving the business forward right now. So there's a lot of push to be able to support these modern workloads like we're seeing on screen here, especially with things like COVID. You hear about this rush for AI and machine learning to really help accelerate research and things like that. And IT has to be able to support those workloads. And really what we've seen is that containers in Kubernetes kind of fundamentally enable teams to use these new style modern applications. They help them leverage, better big data analytics or deploy cloud native applications. Kubernetes is really critical to that cloud native application development type environment. And really OpenShift is one of the best kind of packages to get that in. It's really kind of a complete platform to help you deliver and support your business. So in general, right, if we want to support things like AI and machine learning or IoT, we need, kind of what we're looking to do is help deliver value to our customer, whoever that may be, faster. And we don't want to, as IT administrators or developers, have to re-architect depending on where we're going. If we're going to the edge, or we're going to Azure or AWS, or even into our data center, we don't want to have to, kind of lift and shift every time we want to go to a different environment. We need kind of a unified platform across all of the different environments, on-prem, edge, and in the cloud, to really deliver our applications. And this is where Kubernetes and specifically OpenShift can come in, is help teams have this unified platform where they have the same development experience, the same deployment experience, and the same management experience, no matter what underlying infrastructure they're on. So what are the challenges, right? If we're going to be deploying containers, really the challenges that people see are security, first of all, and then day 2 management, things like upgrades and stuff like that at scale can be really challenging. And then delivery, as far as like complicated workflows, A/B deployments, blue-green deployments. That's where OpenShift can really help out. Red Hat has, long been the king of Linux, and containers are just Linux. And so with OpenShift, you get long-term support from Red Hat, and they take their container security really, really seriously. You get Just like you may have gotten RHEL before, there's a OpenShift verified container registry where you can pull known secure images and base your builds from there. OpenShift provides a way to do day 2 management through the operator framework that we're going to talk about a little later. And they have frequent releases. So, all these security updates and stuff like that are released over the air to OpenShift with an automated upgrade or update process through the operator framework. And this really helps you kind of deploy containers at scale and manage them and not have to worry about it. And then finally is, on the application side of things, OpenShift isn't only about the infrastructure, it's also about the application delivery. OpenShift provides concepts like CI/CD pipelines, whether that be through Jenkins that has integrations, or more modern stuff like Tecton, which is Kubernetes-native CI/CD pipelines. And then also like complex deployment workflows like A/B testing or blue-green deployments. Those are all supported, or service mesh or serverless. Those are all supported in OpenShift. So in general, right, when we talk about OpenShift, what is it and how is it different? OpenShift is really all the way from the OS layer. It's Red Hat Core OS, an immutable operating system, all the way up through Kubernetes to application services. And so what's really cool here, and what I wanted to highlight with this slide is when you do updates in OpenShift or scaling, the OS happens at the same time as the Kubernetes updates, which is really interesting to have those coupled together. So through the single management plane, you can do patch management or OS management that's managed by the same platform as the top of the stack with your applications. And so they put all this together with a lot of automated operations and bundling open source applications together in a verified release. So this is just kind of to show you what it is, right? They take all these open source solutions. Red Hat's actually the #2 contributor to Kubernetes after Google. And they bundle all these open source technologies together, they support them, and then they put them together in one OpenShift release, which is really cool. And so just in general, right, to touch on the over-the-air updates again real quick, you just pick a version, you click update, and you click go. And you don't have to worry about migrating applications from different nodes or availability of the management cluster or anything like that. OpenShift manages that for you, and it's just kind of one button. So without any further ado, let's get into some cool stuff real quick. I'm going to start with kind of the installation experience and what that might look like. Alrighty. Here. Okay. So in general, if I want to get started, you have this Red Hat Cloud portal for installing and managing your clusters. So I can see right here at the top, let me get my WebEx stuff out of the way. These are the clusters that we have running. You can manage your OpenShift licensing through here. And then if I click into like our pre-baked cluster here, you get some basic top-level metrics in the cluster manager. How much utilization am I using? What version am I on? Are there updates available? And where is it deployed? Beyond that, you can see if there's any alerts firing. A lot of these things surface up into the cluster manager here. But let's go ahead and get started, right? So we just click Create Cluster. We can pick a platform. Like I mentioned, any platform is basically any platform out there is supported, all the way from bare metal into the clouds. In this example, we're going to show AWS. So let's click into AWS. And there's two concepts in OpenShift. There's user provisioned infrastructure, which is kind of like bring your own machines, or installer provisioned infrastructure, which is my favorite, where OpenShift will go and create everything for you. So in Amazon, this means networks, this means VPCs, this means security groups, load balancers, all of those resources, OpenShift is automatically going to create for you. So they give you a little download button to download the binary, and then you have a pull secret, which we don't need to get into. That's just downloading. It's like your credentials. What does installation look like? Well, just type OpenShift install, create cluster. I pick my SSH key. I pick my platform. In this case, I'm going to go to Amazon. I pick my region. I'm going to go with US West 2. And then I pick my DNS. So I have this DNS zone labs.red8.cloud set up. I'm going to pick that. I'm going to give it a name, so demo cluster. And then I paste my pull secret. And what this installation program is going to do is go and provision all of my resources in Amazon. This part actually takes between 50 to 45 minutes, depending on the size and stuff like that. You can see that we're already starting to create some resources. And I won't make you guys wait through that. We'll just jump into one of these clusters. But if we peek into EC2, we'll start to see some instances coming online here soon. Crash. This is our existing cluster here, this demo 1. We should start to have a VPC being created. And this is our VPC. You can see that we're already provisioning resources in Amazon. And by the end of this demo, we'll have another cluster online. But for now, let's go ahead and jump into our pre-built cluster. And I just want to give a quick overview of what things look like. I'm very much a test drive type person. I like to see it. So if we go back to our clusters, look at our demo cluster here. I can just click Open Console right from this UI. It's going to drop me right into the OpenShift cluster. So this is a running cluster. And right away, I can see some really cool information going on. On the right, I see what's happening. Are we updating machines? Are we updating deployments? How's my utilization look? I can change my time frame the past 6 hours. And really, how big is this cluster, right? Over here on the bottom left, how many nodes, how many pods, what kind of storage am I provisioning with PVCs? You can see I also have an update available. So let's kind of go down that list a little bit. Projects, we can dive into the different namespaces. I'm in the administrator view right now, so I can see everybody's namespaces and dive into them if I need to. But more interestingly, right, we can look at workloads or any of the native Kubernetes resources. We can dive right in here and see those. But all the way down to stuff that administrators might care more about, like alerting. So right out of the box, we have the Grafana and Prometheus set up. We have, you can see here, 133 alerts out of the box set up to tell you if your cluster is healthy. We could scroll through any of these and see what's going on, right? Like Kubernetes API is down. That's something we might want to know about. I don't have to go set that up as an administrator. It's here, it's visible through the console, and it's kind of ready to go right out of the box. You can see we can jump into kind of some example metrics right here through the UI as well. But like, let's say, I want to scale or something like that, right? I can jump into this compute tab, and you can see my list of instances. I want to scale in the 2B region. Couple button clicks, and OpenShift is going to go make new machines for me and add them to the cluster. So scaling isn't really an issue anymore. I don't even have to mess with making AMIs or provisioning user data. It's all taken care of by the platform. And beyond that, I can set up things like auto scaling to let the cluster scale as it sees fit. And then kind of the final two things I want to touch on here from the basic admin overview. I can set quotas on different resources. So like, let's say, I'm provisioning this book info namespace. You can set resources. So I only want my developers to be able to use 2 gigs of memory or 5 CPUs, right? You can set that type of limit here so that people can't overuse what they're provisioning, right? Like you don't have this runaway resource problem. You give people a little box to live in and they can do whatever they want there. So that really helps from the administrative standpoint. You can kind of set limits on what people are allowed to do right from the console. And then finally, so we saw we had an update available. Here's the cluster settings view. All it is this one button here. I could do this right now. I don't want to have any hitches in the availability. It's really just a one-click action. You pick your version and go. And then what happens, right, is OpenShift actually runs. I've mentioned operators a couple times. OpenShift runs itself through cluster operators. And you get a status. These are all the different services, if you will, of what OpenShift is. And an update will go through and update each of these different things like auth or networking or ingress, and update each of these operators, for that kind of automated management. I don't have to worry about any of these different pieces. All of these pieces are included as part of the operator pattern and style of management. So that's kind of a quick overview. You can view any of the resources. You can set resource quotas. You can view metrics and alerts, all right from the console. And operators kind of run the backbone of all that stuff. All right. So what are operators anyway? This is something probably one of, I think, the most important things to happen in Kubernetes in quite some time. So I wanted to kind of go over what they are and talk specifically about how OpenShift enables people to use kind of this or have this cloud-like experience, and administrators don't have to worry about day two. So as we start to adopt Kubernetes, right, people are talking about it, and you're like, okay, let's try it out. You probably have heard that it's great for web or stateless apps, right? And that's kind of how people get their foot in the water, right? You might deploy some simple Kubernetes constructs like replica sets or deployments. You're just kind of getting going. But what tends to happen is that you really see, all the benefits of that. The auto healing, you see the auto scaling, things like that, and the availability you get from Kubernetes, and people want to extend that, right? And so people start to move towards putting stateful apps in Kubernetes. What if we put our database in Kubernetes? What if we put Elasticsearch or MySQL, or we start to provision storage in Kubernetes and get more stateful apps, right? And as that adoption picks up, ultimately you end up with distributed systems like Spark or Hadoop. And there's some needs that start to surface along with these types of distributed complex systems that you're doing on Kubernetes. And those needs are around, like, how do I scale a MySQL database? Or how do I balance data across an Elasticsearch cluster? And so there's a lot more application level needs that start to surface as you get to more stateful apps and complex distributed systems. So now that we're doing that, right, we need a way to manage those in a Kubernetes native way. And that's where the operator framework comes in. And really what it is you're taking these Kubernetes concepts and you're codifying them, or you're codifying the needs of managing your complex applications into an operator. So what that means is an operator checks for the state of a system, and remediates if necessary. It's kind of like day two lifecycle management. And really kind of some of the best examples of this are like putting MySQL on Kubernetes. If you want to scale out your read replicas, there's certain things you have to do in MySQL to enable that. Operator framework takes care of that. So you no longer have to go in and assign replication to different slaves in different zones or things like that. That's all handled by a codified and typically vendor-supported operator for automated day two operations. That includes things like backups or maybe upgrading an application. You might need to upgrade in a certain process. The operator is going to handle that for you. You just do that same kind of one-click style upgrade. And really what you ultimately end up with through a platform like OpenShift is kind of this cloud-like experience where, in the Amazon console, I can just go and, request a Kafka instance. Why can't I do that on OpenShift? With the operator framework, you can. And that's really cool. You end up with the operator hub, which is launched by Red Hat in association with the other hyperscalers or with the hyperscalers. And there's this community-driven operator hub, and then you get the Red Hat and vendor-supported kind of certified operators. And that allows you to get vendor-supported things like MongoDB or Redis, all of your standard enterprise-level applications with automated day two operations through an operator. So you really get kind of that cloud-like experience of, I just want this service. I don't care about what's under it. Give that as a service to my developers. And that's really cool. So what does it look like? What happens is, as an administrator, I decide, we have a license for MongoDB and Redis, let's say, or, Kafka is something that people need. I create a subscription for the cluster, and I allow people to provision those resources through a operator subscription. And this is what engineers or developers might see. Just like they're creating pods or they're creating deployments, they can just say, I want a MongoDB. You can see right here, oops. You can see right here, the kind is just MongoDB. You give it a name, you tell it how many members you want, what version. And this is the really cool part about the operator framework. If I need to upgrade, I just change that version, and the operator is going to manage the order in which we're updating pods, how we're managing the data when we update those pods. Maybe scaling operations are difficult within, like Elasticsearch. The operator handles that, and I just need to tell it what I want, and it takes care of things from there. So yeah, we really get that kind of cloud-like experience right in our containerization. Let's jump into that. Okay. So we were just talking about how the cluster itself runs on operators. So I'm a cluster administrator, and I would like to allow people in my organization to, let's say there's a need for serverless, right? People are starting to experiment with Lambda, but I want to be able to provide that in my container platform. So we have that unified experience. I go over to the operator hub, and I just look for serverless. Would you look at that? There's a Red Hat supported serverless distribution through an operator. Excuse me. And so all I have to do is enable this, and then developers can go and subscribe to from their own projects. We'll see that in just a minute. Another great example that I like to talk about is Kafka. I've had to deal with Kafka before, and it's rather annoying by yourself. I can use the Strimzy operator, which is the open source version of the Red Hat supported version, I think. And by subscribing to this, I'm going to allow my developers to go and request Kafka wherever they see fit. So what does that look like? I'm going to switch over to the developer view here. Oops, we're not there yet. So I'm a developer, and I want Kafka. Just click Add from Catalog, Kafka. And you can see I can create a Kafka cluster, or I can create Kafka topics natively, just like I would in Amazon. I think in Amazon, you can't create things like topics or users directly from it. But it's super simple, right? I have this form type interface. I just tell it what I want the cluster name to be, right? This is going to be demo cluster 1. And we'll label it. We don't need a label right now. How big do I want it to be, right? What type of storage do I want? In this case, I'm just going to use ephemeral because it's developer. And then other options, I just click create, and I'll get a Kafka instance. So, beyond that, for day 2, I want to update this, right? All I need to do is come in here, see the version is 2.4.1. I change the YAML to 2.4.1 like this, and the operator will go and update all of these resources for me. So really, you don't have to worry about it anymore. It's really kind of the way I see it. Often a lot of these things come with support. That's really cool. All right, so that is kind of operators. There's a lot of operators available. So you can see here, like as a developer, I might see I have the option to use service mesh if I want to, which we'll get into later. I can use MongoDB if I like. A lot of different options there. Okay, so speaking of developers, great segue into what the developer experience looks like. So what's really cool about OpenShift, right? Through operators and through kind of the unified OS to the application, unified stack from Red Hat, OpenShift is great for administrators, right? It makes my life easier. Whoa, sorry. Makes my life easier. But what about the developer, right? Let's not forget why we started this Kubernetes thing in the first place. It's about the developer. And what's great about OpenShift is that it really kind of is targeted at developers. We get self-service infrastructure, like we just saw with Kafka and operators. And no matter what you're using, right? There's options out there for developers to work and deliver applications quickly. So OpenShift supports a load of different options from serverless to like there's a lot of different Java frameworks that are supported, or Python, or whatever you like. And developers can access all of this supported, all these supported runtimes and services through self-service provisioning, and they get consistent environments, like we were saying. Infrastructure anymore. They just worry about OpenShift. And OpenShift exposes metrics to them, which is great. And also a lot of automated build processes and pipelines kind of happen right out of the box. So we'll kind of show what some of that experience might look like in just a minute here. Yeah. And then one of the other things I want to talk about is kind of this next gen type stuff that we're seeing a lot of buzz about if you're on Hacker News or Reddit. And so like service mesh, right? Service mesh is this hot new topic. It's really great for microservices. And that's provided as a first-class citizen in OpenShift. We saw this, the serverless operator. And that provides Red Hat supported distribution of Istio and Kiali, which is the monitoring and application tracing as well. And that also enables serverless. So you don't have to worry about Lambda. Actually use serverless yourself through your platform on-prem, and you can have a unified serverless layer through Knative, which is kind of the upstream distribution of serverless for Kubernetes. And you don't have to worry about writing Lambda versus Azure functions. You can have a unified layer there as well. So OpenShift supports right out of the box all this next-gen stuff, and we'll jump into that here in just a minute. What does the developer view look like? So I saw a question pop up just now about Helm. So I'm focusing a lot on the operator framework right now, but Helm, yes, is supported. Under the covers, this is all just native Kubernetes. And I believe in an upcoming release, Helm will also be exposed in the catalog like we saw. So anything you can do in native Kubernetes, you can do in OpenShift. So frameworks like Helm are 100% supported. Okay. So I'm a developer, right? I log in, and this is the console I see. You can see I'm in the developer view over here on the left. And this is great because I get a little less information than the admin view, which is good, actually. as a developer, I don't need all that nonsense, right? What I care about is where's my application, is my stuff running, and what does it look like? So you get a similar overview like this. You can see I see utilization, right? How many pods am I running in the same kind of events, but these are specific to my application, right? So I can see these metrics of my application in the demo2 namespace. And I can browse them just as I might in any other, view. I can jump into the pod logs here, right? Looks like I'm doing some reconciliation. I can jump into a terminal on that pod if I want to, right? All from within the console here and do some troubleshooting. So right out of the box, right? Pretty powerful. I can do a lot of the stuff I need to right from here. But like, let's say I want to prototype, right? Like I'm here, let's just get started. So we just click here and add. And you can see these are kind of the options that are laid out for how I can deploy things. At the simplest level, I can deploy from a Docker file, right? What's actually going to happen here is when I'm doing this, right? There's kind of a pre-packaged build process, build and release for building from a Docker file. I just need to pop in like a Git repository. It's going to build my Docker file, deploy it, and expose a container port for me. I don't need to worry about writing that pipeline. OpenShift provides it. I can deploy a container image directly, right? Go deploy Alpine. But really where we start to see some cool stuff happen is like, I have a Git repository, and my Git repository is written in .NET, right? Through things like source to image and cloud native build packs, OpenShift will take my code, build it into a Docker file, and release it for me. What does that look like? I'll do an example with a Django application. So we also have, this is the developer catalog where you would see like up and coming Helm releases, or .NET Core and Postgres, right? Here's a template, or maybe Kafka or Mongo. This is where we kind of expose everything. But like, let's deploy a Django app, right? So I have a Django app. It runs Postgres. Let's go ahead and create that. Give it a name. Live demo Python. And then we will put in a Git repository. I can set things like how much memory do I want to give it? How big is the volume, right? 10 gigs, 1 gig. Let's go to my GitHub. And I have, this is my Django repository. And take that, paste it right in here. And OpenShift is going to do a lot of things now. It's going to go and clone my source code, it's going to build my source code, and it's going to expose it live for us right here. So if I go back to my project details, trying to catch it while it's happening, you can see right here this live demo Python under workloads. I've started a build right here. Over on the right, we see routes at the bottom. Where is this application going to live? We see services. We see builds. How are we creating this application? And then ultimately at the top, we'll see pods, which is the running instances. I can click View Logs. It's going to show me right here how it's building my application. Give it just a minute here. Installing all my pip applications, right? This is through source to image. It's taking my Django application, building it, and then it's going to release it. It's a full-blown CD pipeline. Okay, so I pushed it to the internal registry. We just go back to our workload details right here. You can see I'm now creating a container. So immediately, right? This has been less than like 2 minutes. I've taken my application, I've deployed it, and it's going to be visible to me. Once this finishes creating, we'll see it come online right down here. Demo gods frowned on me. Let's give it just a minute. All right, that's why I pre-baked one. So I've run a very similar build here for this example. You can see I've gone through. Thanks, John. That's what I saw in the logs there. But I want to keep moving forward with this. So one of the cool things that we can do, right, if I look at my build config here, right down at the bottom, webhooks are automatically provided. So I can take this webhook URL and connect it to my GitHub. So if I go in here and I make a change, let's say, right? This is my welcome page. Here's my application online. I forgot to mention that. There's the Red Hat OpenShift demo. I make a change. I'll go down here to the title. We support CI/CD. I commit that. Without any specialized knowledge of Jenkins or any kind of delivery system, my commits are going to directly build and release this application. So you can see I've triggered a build. It's running over here. And after a few minutes, we'll get a new header in here. I'm just going to wait for that build to finish. Almost there. And then once this build finishes, it's going to trigger a new pod to be deployed, and we're going to see those changes live. And there's a few different ways. You know, if you need more complex deployment strategies, that's available to you. You can do blue-green deploys or A/B deploys. That type of stuff is possible as well. All right, we've spun up our new instance here. If I go to the URL, you can see that my changes are live. So, you know, just in like 5 minutes here, we've got a full continuous delivery pipeline running. Kind of from. All right. So one of the other things I want to touch on, right? That's great. But what if we're looking at kind of a more complex application, right? It's great for prototyping, but what about like kind of live stuff? What if you're running microservices? And we've talked about service mesh. What does that service mesh look like in OpenShift? Here's an example of a project that has, you can see here, 1, 2, 3, 4 different services running. I get this cool little overview of the topology of them, who's talking to what, and kind of right out of the box, right? We get really great support of service mesh and microservices. So, like, let's take a look at you know what that really means. So if I look here, I have Kiali. So Kiali is going to show me the service mesh. Really, you'll see it. So between all these microservices, OpenShift Service Mesh is monitoring who's talking to what and what the success rate is of things like that. And you can do things like balancing between different versions of a service, right? This is all provided through Istio. And you get really great metrics and visibility out of all of this microservice communication right out of the box. So if I were to page, this is our application. Oops, the application here. Give me just a minute. We're going to send some traffic to it. Navigate there ourselves. So here's our application. Now there's a few different pieces involved here. And we're balancing between different backends of this review here. In this case, we're just kind of going to multiple different versions. And you'll see that by the appearance and disappearance of the stars, we're actually going to different versions of the application on the backend. Through Istio, we could change the weighting of this balancing. And this is useful for like kind of progressive rollouts or A/B type deployments. But there's several different services involved here, and we can see that right through Istio, who's talking to who, is it being successful, and kind of what's going on there, right? So it's all visible right out of the box, pretty easily. See that here in the topology view as well. I have a Ruby application, front page is Python, there's Node.js and Java all involved here. So that's kind of the end of it, just showing kind of the integration into Service Mesh and what's available right out of the box, and kind of the visibility that OpenShift gives you with kind of zero setup. It's pretty easily and very powerful for developers. So that's it for me right now. I guess I'll go to questions.
Hey, Stephen, we do have one question from Qing Yao Wang. He says, does OpenShift use Docker CE or Docker DE? That's his first question, then I have one more.
Yeah. So OpenShift actually doesn't use Docker, which is an interesting concept, and I'd love to get into it in kind of a technical deep dive session. But there's a new containerization. There's a spec called the OCI, the Open Container. If you create an image with Docker, it will run on OpenShift, is the short answer. It uses CRIO on the back end, which is the upstream Kubernetes container engine.
Okay, and then follow up to that, he says, will OpenShift replace UCP or DTR?
I need a little. I'm not sure what UCP or DTR are. Docker Trusted Registry, and maybe I don't know. I need a little more detail on what those are.
Ching, if you want to chat me, I can the answers to that I can pass those on to Stephen. But we do have a couple more questions. A couple from the Cypress team. Mm-hmm. Number one, how mature is this technology, and how widely has it been deployed and accepted?
So great question. I guess it depends on what technology you're talking about. Kubernetes has been around for a long, long time, and OpenShift has been around just as long, I guess you could say. I started using OpenShift, I think in 2015, maybe a little sooner, maybe it was 2013, but with the 3.4 release. Safe to say, it's production proven, it's production ready. People are using OpenShift at massive scale, and it's been proven out like all the way, you can use it with just 10 containers and getting started, but you can use it with hundreds of thousands. It's battle tested and proven. It's rock solid. I've run it in production. Licensing crossovers. That's a very difficult question, pretty open. SAP and Oracle and stuff like that are, it depends. That sounds like you're talking about the application layer, especially with those two, that can get a little funky. So it's difficult to say with that right now. I'd love to dive into it with you if we get more specific, maybe in another follow-up. So Security compliance and microsegmentation. So great question. So Service Mesh has the ability to block communication. So we can use things like Istio to block communication between services. We can use things like OpenShift has an integrated SDN that allows you to apply network policy. So if I jump back into the admin view, sorry, let me say the question for everyone else. To expand on it, I guess, how does OpenShift address IT security compliance and integration, LAN microsegmentation, things of that nature? So at the most basic level, you have services that communicate with each other, routes that are exposing those services externally. Look at demo 1, I have routes. And then we have network policy. So network policy is what services are allowed to talk to who, and it's basically microsegmentation. So if I go in here and I want to create a network policy, sorry, I'm going to move my chat window out of the way. You can see that I can block communication between different services. I can limit traffic between different nodes. So microsegmentation, totally supported. And as far as like security compliance and things like that, typically you do vulnerability assessment on the container level. So you can use a product like OpenShift Quay is their registry. It'll do vulnerability scanning and assessment of your containers, and you can allow container vulnerability results, for example. So that was a long-winded way of saying it's designed for security. Security is one of the main things that Red Hat's about with OpenShift. Is how can we, manage compliance, manage vulnerabilities, and deal with networking.
And then the last one, Stephen, is from Brandon AM. What does the licensing model look like?
Licensing, actually embarrassingly off the top of my head, I can't remember. I think it's per core. So you can start very small. You can start with a basic cluster, which is pretty small. Yeah, it's by core. Thanks, John. So it's by core. Short answer. Are there any other questions?
Be sure to chat if you have any last questions.
I guess I can circle back real quick on that question about does OpenShift use Docker CE or Docker Desktop Edition? I just want to emphasize that it's fully compatible. Your developers can be using and developing with Docker, and then you can deploy those images onto OpenShift. So I just want to make sure that that's called out.